So we are beginning unit 4 now, and this unit is all about exponents and powers, using order of operations to solve those, exponential notation. So learning target for indicator 10, as you can see, we have powers and exponents. And learning target is I can use integer exponents to show repeated multiplication of rational numbers. Okay, so let's look at the vocabulary that we have over here. A power is what? A power is a product of repeated factors. Okay, so I am going to be repeating this factor. So this is the power. Okay, so if I just have something like 1/2 to the fifth power, so so that is the power, the repeated factors that are being used, the product of repeated factors. Okay, the base of a power is the repeated factor. Okay, so this 1/2, this is called the base. Okay, this is the base because this is the factor that is being repeated. Okay, and then we have the exponent of a power. This indicates the number of times the base is used as a factor. Okay, so this is the exponent because this is telling us the number of times the base is used as a factor. Okay, so let's look at this. I am going to, it's 1/2 to the fifth power. So 1/2 is used as a factor 5 times. Okay, so therefore this is 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Okay, so as you can see in this case here, 1/2 is used as a factor 5 times. Okay, 5 times. 1, 2, 3, 4, 5. All right, so this is basically just an introduction of what the base is, what is the power. And when a number is written with a power like this is called the exponential notation. Exponential notation. Okay, so let's go on once again. If I write, let's say I give you 5 cubed. If I give you 5 cubed, okay, and if I look at that, uh, this is my base number because that is the factor that I am going to multiply by itself based on what the exponent is. And the factor that I'm repeating is 5. So this is the power. Okay, this is the power. And basically, what does this mean? This means the factor, which is 5, is multiplied by itself how many times? See, 3 times. That's the exponent. 5 times 5 times 5. And that's what that means. All right. So let's do some quick examples. And how you read numbers or the exponents is very important to understand. So first and foremost, any number to the 0 power is going to be 1. Okay, so let's say I give you this 3 to the 0 power. Any number to the 0 power is going to be 1. Okay, then if I say 3 to the first power, so to the first power is going to be 3. All right. And then 3 to the second power, we actually say 3 squared. Okay, so we say this is 3 squared. Okay, so we say 3 squared. I just want you to see how you write it, how you say it. It's 3 squared. Okay, And then 3 to the third power, you actually say 3 cubed. Okay? And then you have 3 to the fourth power. 3 to the fourth power. So this one is 1. This is 3. 3 squared means what? 3 times 3. Okay? Taking the factor and you're multiplying it how many times? All right? And then you have 3 cubed, which is 3 times 3 times 3, because that's the exponent. All right? And then we have 3 to the fourth power. This means 3 times 3 times 3 times 3. So as you can see, we are writing it based on whatever the exponent is. Okay? So we are now going to write numerical products as powers. So first thing, if I'm giving you a question, and let's say I give you a problem, -2 times -2 times -2 times 1/3. Okay. Or let me do 3/4. Doesn't matter. 3/4 times 3/4 times 3/4. Okay, times 3/4. So let's say this is my question, and write the expression -2 times -2 times -2 times 3/4 times 3/4 times 3/4 times 3/4 using exponents. So first thing I need to look at is what are the repeated factors, and I can see that the repeated factors are -2 and 3/4. Okay, so if I'm going to write this as an exponent, how many -2's do I have? 1, 2, 3. So I am going to write it like this: -2 cubed, because there are 3 of them. All right, times, okay? Then I'm going to look at how many 3/4 do I have. So how many 3/4 do I have? 1, 2, 3, 4. So to the fourth power. Okay? So when I end up writing this, we are going to like just count how many of the factors of each there are, and then that becomes my exponent. Okay? Let's do one. Writing numerical expressions as a power. So let's say if I had another example, and if I had 4 times 4 times 4, okay, and then I have times -9 times -9 times -9 times -9 times -9. So let's say this is my question. And now once again, write this expression using exponents. So I'm going to again see how many factors do I have. I have 4 as a factor. And then I look at how many 4's do I have. So I have 4 cubed, right? Because there are 3 of them. So I have 4 cubed. And then times, how many -9's do I have? 1, 2, 3, 4, 5 to the fifth power. Okay, so when I am writing the expression using exponents, that's how I am going to write it. I can also write algebraic products as powers. Okay, so I'm going to erase this. So if I have algebraic, expression, let's say I have A times B times B times A times B. So let's say I have a question like that, and it's saying to write the algebraic products as powers. So first I look at what are the repeated factors. Okay, so I can see the repeated factors are A and I have B. Okay, so those are the two repeated factors. So first I'm going to use the commutative property of multiplication, and I am going to switch them around. Okay, um, so I am going to do, I'm going to bring this over here. I'm just going to do commutative property of multiplication. A times A, because I'm trying to put the same factors together. Okay, I'm trying to put the same factors together, times B times B times B. Okay, now when I look at this, I'm going to look at how many A's do I have. I have two. How many B's do I have? I have three. So when I'm going to write this out, I am going to have this answer is equal to A squared, because there are two factors of A, times B cubed, because I have three factors of B. So the base A is a factor two times, and the base B is a factor three times. Okay, so that's how I write the algebraic expression. Okay, now um, let's say I have to evaluate powers. To evaluate an expression with a power, we are going to write the power as a product, and then we are going to multiply. And when evaluating expressions with powers or more than one operation, it is important to remember to do the order of operations. And order of operations is nothing but PEMDAS. Please excuse my dear Aunt Sally. Basically, P for parentheses, E for exponent, multiplication and division go left to right if those two are the only two left. And then you have addition and subtraction that also go left to right if only those two are left. Okay, so we're going to follow the order of operations. Okay, simplify the expression inside the grouping symbols. In order of operations, you're going to evaluate all powers, perform multiplication and division in order from left to right, and then perform addition and subtraction in order from left to right. Okay, but before I do that, I just wanted to show you one more thing so that we do not confuse this. Okay. Sometimes you are given problems with the parentheses or without the parentheses, and I want to make sure that you learn not to make a mistake when we are actually evaluating expressions. Okay. So let's say I have negative 2 to the fourth power. Okay, and then I have negative 2 to the fourth power. All right, now this is the one where sometimes you all make mistakes on, so just be careful on this one. In the first case, it's telling you that negative 2 is being used as a factor 4 times. So in this case, what are we doing? Negative 2 times negative 2 times negative 2 times negative 2. All right. And when I do that, I know that negative times negative is going to give me what? Is going to give me a positive number. So negative 2 times negative 2 gives me positive 4. Okay, times, I can do this again, negative 2 times negative 2 gives me what? A positive 4. And so 4 times 4 is 16, and that's a positive number when I am multiplying this and simplifying. Okay, in this one, be careful, the entire negative 2 is not within parentheses. So it actually means that 2 is used as a factor. And so this is how you write it. The negative sign comes outside, and it is 2 times 2 times 2 times 2. Okay, so when I solve 2 times 2, 4 times 2, 8 times 2, 16. Do not forget there's a negative sign outside. So this one turns out as negative 16. So just be careful with these ones, okay? So if I am going to now start evaluating numerical expressions, let's say I have, so let's say my question is negative 2 cubed, negative 2 cubed, okay, plus 3 and 5/10 squared. 3 and 5/10 squared. All right. So according to the order of operations, what are the first evaluations you will need to do? So based on this, I can see for PEMDAS, first thing I can see over here is that I'm going to have to work on the exponents. Okay. So if we organize this, this is what this means. This means negative 2 times negative 2 times negative 2. All right. Then I have plus 3 and 5/10 times 3 and 5/10. So when I say negative 2 times negative 2, I get a positive 4, right? So this gives me positive 4 times negative 2. So positive times negative is going to give me a negative answer, right? Opposite signs gives me negative. So 4 times negative 2, so I get negative 8 over here, okay? And then 3 and 5/10 times 3 and 5/10, I am going to get plus 12 and 2500. Okay, so 3 and 5/10 times 3 and 5/10 gives me 12 and 2500. Now we can see that these are opposite signs. We've done integer operations in the past lessons. So since they are opposite signs, I am going to take the absolute value of the bigger number and subtract the absolute value of the smaller number. So basically, I am subtracting 8 from 12 and 2500, and I'm going to get 4 and 2500. And then what is the sign in front of the bigger absolute value? It is positive. So therefore, my answer to this problem is going to be 4 and 2500. Okay, so that's how we evaluate expressions. Let's also go into an example with an algebraic expression. We are going to evaluate an algebraic expression. So let's say I give you a squared, evaluate a squared plus b to the fourth power plus b to the fourth power. Okay, if a is equal to 3, if a is equal to 3, all right, and b is equal to 1/2, b is equal to 1/2. So before we can evaluate this, we are definitely going to look at how many times are the factors repeated. So we are, of course, we can see A is repeated 2 times, B is repeated 4 times. And then we've also been given the values of A and B. So we are just going to go ahead and substitute those values, okay? So if it's saying A squared, A is 3. So this is 3 squared, and then it's telling me what b is. B is 1/2, so I am going to substitute that value, and this is going to be 1/2 to the fourth power. Okay, and what that basically means is that this is 3 times 3 plus 1/2 times 1/2 times 1/2 times 1/2. Okay, so this is how we're going to write it. And then I know that 3 times 3 is 9 plus 1 times 1 times 1 times 1 is 1, over 2 times 2 is 4 times 2 is 8 times 2 is 16. So this is 1/16. And then when I take a whole number and I add a fractional part to it, this becomes what? We have 9 whole and 1/16. So my answer for this is 9 and 1/16. Okay, so um, let's do another problem for evaluating with algebraic expressions. So if I give you d cubed, so I give you d cubed, okay? And to this, I'm going to do plus c squared minus 2 plus c squared minus 2. And then if c is equal to -4, if c is equal to -4, and d is equal to 2/5. Okay, so I've been given this. So we are now going to substitute. We're going to move through the steps to evaluate the expression. And it's telling me that d is 2/5. Okay, so instead of d, I am going to substitute the value. And this is going to be 2/5 cubed plus, what is c? So I'm going to look at c has been given to me as -4. So let me do this. Okay, I'm just going to put that so that I can see what I'm doing. And c has been given to me as -4 squared. All right. And then I have minus 2. Because that is basically what the expression is. All right. Now, please remember that I did not put the minus sign outside because it told me the entire value of c is -4. So therefore, it's -4 times that's being used as a factor. All right. So that is why I'm writing it within that parentheses. Okay. Now I am going to just go ahead and I'm going to do 2/5 cubed. All right. So this means what? This means 2/5 times 2/5 times 2/5. Okay. Plus, okay, plus what is -4 times -4? -4 times -4 is going to give me 16, right? Because negative times negative is what? Positive. So -4 times -4 gives me 16 minus 2. And what is 16 minus 2? 16 minus 2 definitely is, this is going to be 14 plus 2 times 2 times 2. 2 times 2 is 4 and 4 times 2 is what? 8 over 5 times 5 is 25, and then 25 times 5 is 125. Okay, so now you can see I have 8 and 120 over 125, which is the fractional part, and my whole number is 14. So the whole and the fractional combines and gives me 14 and 8 over 125, and this is going to be my mixed number. Okay, so once again, indicator 10, it's just how to write the powers and exponents out and then to evaluate them. And in the evaluation, all you're doing is the order of operations. Do not forget PEMDAS, parentheses, exponent, multiplication, division, left to right, and then addition, subtraction also left to right if only those two operations are left. All right, and that concludes our indicator 10. Have a great day.